Hey guys, so today we're going to be talking about the difference of squares theorem and solving equations that have the squared term. And so looking at this, you can see that these two equations, x squared equals 4 and x squared minus 4 equals 0, they're both the same equation. They're just in two different forms. One is written as a difference of two perfect squares, okay? And then the other one, basically they added the 4 to the other side, okay? And so in a previous lesson in our book, we learned about factoring a difference of squares, but we'll just go over that one more time. So again, this is a difference of squares. And one way to think of it is, if you think about normally when you factor these trinomials, you're trying to think of two numbers that when multiplied give you the last number, but when added give you the middle number. And notice there's no middle number here. Normally we have like a term with just an x, and we don't have one here, which means that there's a 0, basically. If you were to think about rewriting this, you could say x squared plus 0x minus 4 equals 0. So you could think of it like that, using that previous method of factoring. And so if you thought about it that way, you could think, okay, what two numbers when multiplied give you a negative 4, but when added give you a 0? And that would be a plus and a minus 2. And you can put them in whichever order you want. You can have it as x minus 2 and x plus 2, or vice versa. So that's how you would factor that. Another way is just thinking, if you have two perfect squares, and it's a difference of two perfect squares, that can be factored to be a plus b times a minus b. So a plus b times a minus b, where you basically take the square root of this term, and that's what goes here, and then you take the square root of this term, and that's what goes here, and then you have a plus and a minus. And again, this is of the form where if you were to FOIL this back out, the middle term would cancel, the middle terms would cancel the inside and outside terms. And so you'd end up with just this form. So solving this, back to solving this, when you factor and you get it like this, basically you set each factor equal to 0. And then if we add 2 to this equation, we get x equals 2. And we subtract 2 on this equation, we get x equals negative 2. And so it says, in the same way, equations that are in this form, like this, right? Equations that are in this form, if you were to solve them, notice we get two different solutions when we solved this one. It was x equals the square root of 4, and that would be a positive 2 and a negative 2. Okay? So if you were to try to get x by itself on this one, you would take the square root of both sides, and you would get plus or minus 2. Okay? So they're just saying that any equation in this form can be solved by thinking of, okay, your two solutions would be p would equal positive q and p would equal negative q. Just like this. And so it just says in here, it's important to note that we get two solutions to this equation, one positive and the other negative. And the result is important and useful, and we call it the difference of two squares theorem. So it says if p and q are real numbers such that p squared equals q squared, then p equals q or p equals negative q. And so this is helpful because what we're going to do is solve equations that are in this form as we go through, and it'll just help us instead of having to think of factoring for these. So let's look at the first example. So the first example is x plus 17 squared equals 2. So if we have one like this, instead of foiling this out and then trying to get all the terms to one side and then factoring, you could use this difference of squares theorem. You could take, try to isolate the part that's squared, basically, by taking the square root of both sides. Okay, so you can undo a square by taking the square root. Those are inverse operations. Okay, and if we think about this back up here, of our theorem here, so it's in this form, p squared equals q squared, even though I know this isn't a perfect square. 2 is not a perfect square, but you could take the square root of it nonetheless. But what it's saying is now you can say that this argument here is equal to the square root of this one, the positive square root of that one, or the argument's equal to the negative square root of that. So that's what we're going to do here. And again, we just kind of think of it like undoing the square. So you're taking the square root of both sides. And so this is the argument under here, the x plus 17. So you're saying x plus 17 equals either positive root 2 or x plus 17 equals negative root 2. That's all it's saying. And then from there, you're going to subtract 17 from both sides, and you're going to get a little bit of an odd number, but so we're going to do this on both sides. And so you get x equals root 2 minus 17. And then on this one, you'll get x equals negative root 2 minus 17. Okay? And so another way you can write this as negative 17 plus root 2. So it doesn't matter, I guess, which way you write that. Just know that that's basically how you do that one. All right. Example 2. So we have another one of these. X plus 2/5 squared equals 3. So again, we want to get the argument by itself, the part with the x by itself. So what we need to do is get rid of the squared term. So we're going to take the square root. So we square root both sides. And then we get this left on the left side. So x plus 2/5 equals, again, either positive root 3 or negative root 3. And then from there, same thing, we're going to get x by itself by subtracting 2/5, okay, from both sides. So on this one, when I subtract 2/5, I'll go ahead and put the negative 2/5 first. Negative 2/5 plus root 3, or if you subtracted the 2/5 here, you can get negative 2/5 minus root 3. And so that's pretty much it. I'll do one more example just because I know we kind of didn't see this one in the book, but this is even more simple here. So for this one, they just give you something simple like that. Again, according to this theorem, we take the square root of both sides, and we get x equals root 14, or x equals negative root 14. And then you can't simplify that anymore. So again, this is just an easy way to solve these, is trying to think about getting x by itself by taking the square root first, if it's of this form. Kind of like you see here. If it's got an initial thing squared equals something else, you can always take the square root to get x by itself.